What if the most important force in the modern world was discovered completely by accident, by someone who was just trying to spin will? 2600 years ago on the coast of ancient Greece, a philosopher named Thales was working with a piece of fossilized tree resin called amber. He rubbed it with a scrap of fur to clean it. And something strange happened. Little bits of straw and feathers on his workbench started jumping up and sticking to it, like the amber had suddenly come alive. Thales had no concept of atoms, electrons, or charge. As far as he knew, he'd stumbled onto some kind of magic trapped inside a stone. He called it a mystery of the amber, and in Greek, the word for amber was electron. That single word, born from a party trick with tree sap, would sit quietly in language for over 2,000 years before anyone understood what was actually happening inside that amber, or realized it was the same invisible force that would one day light entire cities. For almost 2,000 years after Thales, essentially nothing changed. People noticed strange electrical phenomena here and there. Sailors saw eerie blue light dance on ship masts during storms and called it a ghost, not knowing they were watching a natural electrical discharge now called St. Elmo's fire. Ancient Egyptians and Greeks read about electric fish in the Nile that could deliver a genuine shock, and some doctors even used those fish deliberately to numb pain, centuries before anyone knew what electricity actually was. But nobody connected these dots. There was no unifying idea, because there was no reason yet to look for one. Then in the year 1600, an English physician named William Gilbert did something nobody had really done before. He spent years methodically testing dozens of materials, not just amber, to see which ones could be rubbed to attract light objects. He discovered that materials like glass and sulfur behave the same way, and he was the one who gave this behavior a proper name, coining the term electricus from that same Greek root. Gilbert didn't understand the mechanism, but he was the first person to treat this strange attraction as a real subject worth studying carefully, not a party trick. Once Gilbert opened the door, the 17th and 18th centuries turned into an electrical arms race of curiosity. In the early 1700s, an English scientist named Francis Hauksbee built a spinning glass globe that glowed with an eerie light where it was labbed, and crowds paid to watch it in candlelit demonstrations, treating electricity as a form of entertainment before anyone grasped its potential. Then in 1745, in the Dutch city of Leiden, researchers built something that changed everything. A glass jar lined with metal foil that could store an electric charge and then release it all at once. It was called the Leyden jar, and it was essentially the world's first battery. People lined up to hold hands in a circle and get shocked together, purely for the thrill of it. One famous demonstration reportedly shocked a line of over 180 guards simultaneously in front of the King of France, and they all jumped at exactly the same moment. Electricity had gone from a philosopher's curiosity to a genuine public sensation, even though nobody could yet explain what was actually flowing through that jar. This is where Benjamin Franklin enters the story. And here's a fact that surprises most people. He did not discover electricity. It had already been studied for over a century by the time he got involved. What Franklin actually did was prove that lightning itself was electrical, the exact same force sitting inside a Leyden jar, just on an unimaginably larger scale. In 1752, Franklin flew a kite with a metal key attached to the string during a thunderstorm, and when the string got wet enough to conduct, he felt a spark jump from the key to his knuckle. It was a genuinely dangerous experiment. Franklin got lucky because at least one other scientist who tried to replicate a similar setup in Russia was killed almost instantly by a direct strike. What if Franklin had simply been standing a few feet closer to that key? We might be telling a very different story right now. But Franklin's experiment did something crucial beyond proving a point. It showed the electricity wasn't just a laboratory curiosity trapped in jars and glass globes. It was a colossal natural force already present in the sky above every single person on Earth. Franklin proved electricity was real and enormous, but there was still a massive problem. Nobody could produce a steady, controllable current. Every source of electricity so far was a single, sudden burst, a spark, a shock, a jolt of lightning, and then nothing. You couldn't build anything useful out of a single spark. The breakthrough came from an unexpected place. A debate between two Italian scientists. One of them, Luigi Galvani, was dissecting a frog and noticed its legs twitched when touched by two different metals, and he became convinced he had discovered a form of electricity generated inside living animal tissue itself. Another scientist named Alessandro Volta disagreed completely. He believed the electricity wasn't coming from the frog's body at all. but from the contact between the two different metals, with the frog's moist tissue simply acting as a conductor. To prove his point, Volta built a stack of alternating discs of zinc and copper, separated by cloth soaked in salt water, no frog required. When you connected a wire to the top and bottom of the stack, it produced a continuous, steady electric current for the very first time in human history. This device, the voltaic pile, was the world's first true battery, and it instantly turned electricity from a fleeting spark you could barely observe into a reliable, sustained tool that scientists could finally experiment with in a controlled, repeatable way. With a steady current finally available, scientists could ask a much bigger question. Is electricity secretly connected to magnetism, a completely different force that had been known since ancient times through lodestones and compasses? In 1820, a Danish scientist named Hans Christian Ørsted was giving a lecture when he noticed something odd. A compass needle sitting near a wire twitched every time he switched the electric current on and up. It was a small, almost throwaway observation, but it proved that electricity and magnetism were somehow linked. That discovery reached a self-taught English bookbinder's apprentice named Michael Faraday, who had almost no formal education but an obsessive curiosity about science. Faraday spent over a decade experimenting, and in 1831 he made the discovery that changed everything: electromagnetic induction. He found that moving a magnet through a coil of wire generated an electric current in that wire, with no battery required at all. Motion alone converted directly into electricity. This single insight is the working principle behind almost every generator on Earth today, whether it's spun by coal, water, wind, or nuclear reaction. Every power point on the planet is essentially just a much larger, more refined version of Faraday's simple coil of wire and moving magnet, which is a genuinely wild thing to sit with. That the entire modern electrical grid runs on one core idea a book founder's apprentice discovered with almost no formal training. It is worth pausing on how strange that is, a decade of patient, unglamorous tinkering behind nearly every light, motor, and charger in the world today. By the late 1800s, scientists finally understood the physics well enough to ask a practical question: could electricity be turned into something people would actually pay for? Thomas Edison believed the answer was light. His team tested thousands of different filament materials, trying to find something that would glow steadily for hours without instantly burning out, an unglamorous, grinding process of failure after failure after failure. In 1879, Edison's lab finally landed on a carbonized filament that burned for around 40 hours, and soon after they pushed that number to well over 1,000. But inventing the bolt was actually the easier half of the problem. Nobody had power lines, meters, or generators built for homes and businesses yet. So Edison also had to invent an entire electrical distribution system, essentially from scratch. In 1882, his Pearl Street station in New York City began supplying electricity to a few dozen customers in Lower Manhattan, the first commercial power grid in history. It's easy to forget that electric light wasn't an inevitability. It was a business Edison had to build brick by brick, wire by wire, one skeptical customer at a time, because most people in 1882 had never even seen an electric light and had zero reason yet to trust it in their own homes. Here's the part of the story people find genuinely surprising. Edison and the future of electricity were nearly derailed by his own staleness. Edison had built his entire empire around direct current, or DC, but DC had a massive limitation. It couldn't travel more than about a mile or two before losing too much power to be useful. A rival inventor named Nikola Tesla, along with businessman George Westinghouse, championed an alternative called alternating current, or AC, which could travel hundreds of miles efficiently using transformers to adjust voltage along the way. Edison saw this as a direct threat to everything he'd built, and he responded with what's now called the War of the Currents, a public campaign designed to convince people AC was dangerous, including staged demonstrations meant to frighten the public away from it. It didn't work. AC was simply the better engineering solution for delivering power across long distances, and by the 1890s, it had become the standard used to build out national electrical grids. Today, when electricity reaches your home from a power plant that might be dozens or even hundreds of miles away, it's traveling as alternating current, which means in the biggest infrastructure battle in the history of electricity, Edison, the man most people credit with inventing it, actually lost. So why does any of this history actually matter today? Because almost every argument happening right now about how we power the world is a direct continuation of these exact same 1800s debates, just with higher stakes. The core physics Faraday discovered in 1831, a magnet moving through a coil of wire, is still literally how a coal plant, a nuclear reactor, and most wind turbines generate power today. We haven't replaced the fundamental principle in almost 200 years. We've only gotten dramatically better at spinning that magnet more efficiently and cleanly. And the War of the Curips never fully ended either, it just evolved. Modern debates about long-distance power transmission, about how to move solar power generated in a sunny desert to a cloudy city hundreds of miles away, are wrestling with the exact same fundamental physics problem Tesla and Edison were fighting about back in the 1890s. Here's the genuinely strange part to sit with. Everything Thales felt as stated clean on a piece of amber, the same invisible force, is now precisely controlled at a scale that powers hospitals, data centers, and entire cities. We didn't invent electricity. We spent 2,600 years slowly learning to have a conversation with something that was already there the entire time, quietly waiting in a piece of fossilized tree resin for someone curious enough to ask what it actually was. Think about it this way. Every time you plug in a phone charger you never see, tuned up by enormous humming machinery you never see. Next time you fled a light switch without even thinking about it, remember that you're closing a chain of curiosity that stretches back through Faraday's coil, Volta's stack of metal discs, Franklin's soaked kite string, all the way back to a Greek philosopher rubbing a piece of tree resin with fur just to see what would happen. Electricity was never really discovered in one single moment. It was slowly, stubbornly coaxed out of hiding by people who kept asking one simple, persistent question. What is actually happening here, and refused to stop until they had a real answer. If you want to see how that same restless curiosity built the modern world piece by piece, there's another story just like this one waiting for you right here.